Hello, good evening, good morning, wherever you are, guys. So welcome again. Today we have the deployment and model monitoring session. Today we have with us Vivek Raja, who is an active AI researcher and working as a data scientist with Nextem. So we are glad he agreed to join us, and give a session on the ML model and machine learning. So today's topic, we are going to give from introduction how you can start with your journey from the machine learning and to the deployment in the Azure ML. So it's going to be a more hands-on topic. Like you all can join with us and do the hands-on. And we are here to help you, and we will be helping out your queries and throughout the session. So without any further delay, I want to ask Vivek to the stage, it's all yours. Now can start your. So welcome, Vivek.
Awesome.
Welcome.
Great to be here in this community. And thanks, Deepak, for a wonderful introduction. So, hello, everyone who are joined in for today's session. So, we will start the session right now. So, let
Vivek, your
me.
cam is off.
Uh, okay, I will switch it on right now. I have some background disturbances. So, I will.
Okay. Okay.
Okay. So, 1 second. Give me a moment. So,
Yeah.
Hello everyone. I hope so. That my mic as well as my screen is visible. So, can you give an S so I can proceed further? Right. So, hello everyone. So today's session will be more on machine learning. If you have been following me throughout this month of August, we have talked a lot about in training machine learning models and understanding the beginning aspects of how machine learning is implemented in Azure and so on. So today's more topic is focused on how to deploy and how to monitor your machine learning models in Azure. But rather than straightly diving into that, we will be actually covering a few concepts on how to train your model that will give a clear understanding and also for the beginners and the newcomers for this today's session. And later on, we will be actually seeing how to manage models and maintain different versions of models and retrieve, delete, and share the models, download the models, and do whatsoever in Azure. And finally, when we are actually convinced that this is the model I'm going to deploy in production, we will see how to protect, what are the different ways we can deploy a model and how that will actually impact your use case and while you are doing the same. So this will be our agenda for today's talk, and let's see what we'll be actually covering in each inside topic. What we are going to do. So first, we'll be actually seeing like what's Azure and how Azure really helps us to train models in a simplest way and how to maintain different models. Then following on, we'll be actually seeing how to deploy the same. So about me, I'm actually from Madurai, Tamil Nadu. I'm currently working as a data scientist at Cortex BCI, and I'm also organizing a developer community in Tamil Nadu. Besides that, Azure, I'm also very much interested in AWS. I'm AWS community builder in machine learning, and I love to write certifications and value my knowledge and expertise as well. So I've done around 16 certifications so far, and I'm Microsoft certified data scientist, AI engineer, data engineer, and developer associate. And besides all these kind of professional and developer related activities, I love to always participate in hackathons. So I have a very good history of participating in hackathons both at national and international level. So now I have stepped aside and I'm sorry. Uh, okay, now I have actually stepped aside and now I'm taking a part of role of a mentor and technical judges in hackathons. And I've been actively speaking and writing blogs and contributing sessions and doing a lot more in AI and cloud particularly. So today's talk will be like the main prerequisites. Even if you don't fulfill these prerequisites, it does not matter. It's only a matter of time where you can catch up on the same. So if you have a basic understanding of how to code in Python, that's very much interesting, and that's the main prerequisite I usually expect. And you should have some knowledge of how machine learning really works. So we won't be actually covering the concepts of machine learning, but we'll be actually focusing on the the operations which is involving around machine learning, like to train your model and do also stuff. So we won't actually dive into what will be the correct selection of models or algorithms, but rather than the implementation part. And to do all these stuff, you definitely need an Azure account. So if you don't have one, it's not a matter. So you can always opt for a free tier Azure account but keep in mind that it might also incur your cost and credits. So make sure that you don't exceed your bills as well. So right now, as we have also set for all these session at top, now it's right time to get started. So since all the code and the concepts which I'm going to discuss in this session, and also the previous session which I've already delivered in a couple of communities, it's all available in my GitHub repos, and code is always available. So you can sit back and enjoy your session. It need not you can It's not necessary for you to code along with me, but rather you can sit along, see how things roll here, and the notebooks and the code will be later on shared with you, where you can experiment on your own. So let's before getting started, it's necessary to understand few things in Azure ML. That is like what really goes on in machine learning. So first, we definitely need to know like where our data is actually existing. So that's data source. And secondly, we need to create a training environment where the machine learning model will be trained. And the third one is where we'll be actually selecting a machine learning model. So as a data scientist or a machine learning engineer in daily aspects, you have a very great responsibility of finding your best algorithm. And once you're actually done with that, you have to prepare a script that will run the model and evaluate the same. So once that is your script is ready, you'll be actually training your model. And your machine learning does not end here. You have to retrain the model, and you have to play with the hyperparameters. And when you actually convince with the accuracy and the model how well it's performing, you finalize the model and you deploy it in your production. So even when it comes to protection, you have to decide on how you are going to deploy that. So what will be the environment where I have to deploy, and what type of deployment options do I choose for, and the necessary stuff you have to do for the same. So what really happens if you're actually a student or a early professional, but who does not know the entire workflow of machine learning and stuff? So as a data scientist or machine learning engineer, it's kind of a little bit challenges that we face throughout our as a part of our job responsibilities, like how to logically create and maintain resources. That includes your environment, your compute power, and so on. So always with the resources which is being created in cloud, there is always a cost associated with that. So we have to keep in mind of that while proceeding with every single action we take in the cloud. And secondly, we have to keep the track of all the ML experiments and runs we do in the cloud. So when it takes, like, I can experiment with 10 different models, and each model I can experiment with several hyperparameters. So I have to maintain like these are the work I have done so far, and go back and evaluate to find the best model out of the same. So you have to keep track of everything you have done so far. And third one is environment. So when you have to create an environment for a machine learning model, it usually involves you to install few packages, or you might to have to pull out a Docker image, and that's where you're going to train your model or deploy your model. So these environments needs to be created, or if possible, if it is already created, you have to reuse in your workflow, and so on. And one of the major constraints which every machine learning engineer faces is the accurate compute power which is needed to execute the same. Not everyone has access to a very good compute power. So infrastructure is always has been a little bit of a constraint. So cloud actually leverages, and it provides us a good compute. So we can spin up any compute of your preference, of either of CPU, GPU, of how many cores and GPUs of memory you want, within a couple of minutes. And you have to only pay for the time you are actually using the compute and how long it runs there. And once we have several models to be trained and so forth, we have to maintain like these are the different versions of the model, and this model like actually performs better than the other models, and so on. And once you actually finalize, you have to deploy and maintain. You have to closely monitor the model so that it does not exceed the relevant accuracy threshold, or I mean it does not drop below the necessary accuracy threshold, or else it requires you to retrain the model, and so on. So with these, in the big picture, there are several constraints which is involved in several parts of our workflows. So this is actually maintained and helped by Azure ML to do all the stuff, so that it makes the work of a data scientist or machine learning engineer much more easier. So the first session will be like how to train your model in Azure ML. So I won't actually deep dive into the terminologies here since those are actually covered in my previous talks, but I'll just give a simple overview of everything so that we'll all be on the same page right now. So instead of, I don't have anything in my presentation, rather I will be only focusing on my code. So let's jump back to my actual code base. So here it is. So actually, there is an end-to-end implementation of machine learning, which I have done here. This is not your actual code base, which you actually see in Microsoft documentation, so and so. So it's like I have referred a couple of blogs and documentations, and I pulled out a structured way of a learning machine learning in an easier way for beginners, so that you can cover from creating your data set to deploying your models at the final. So this notebook is everything for everything, and this can help you to create do wonderful stuff with that. And I will share the code with you later on, and where you can find the code and so on. So this requires us to create an environment first. So when it comes to machine learning, you have to go to your portal, so which is your Azure machine learning portal. So once you go there, you have to create your machine learning resource. So which is like I have already created mine. So machine learning, go and create one and give the necessary details of resource groups and workspace name and so on. So once that is done, your machine learning resource will be actually available. So this is the one which I've already created, and that's called deploy WS. This is my workspace which I've created for myself. So this is where we will be actually seeing what all we have done so far and everything. So go to Machine Learning Studio and launch this one. And once you're done, let me increase the size so that you can view the code much more better. So I hope so. This is better. Yep. Okay. So the first thing is to you have to set up your environment. So create an Azure account with your subscription. Go and create your machine learning resource as I showed you before, and provide a name for your workspace and container registry, and launch your machine learning studio. So our machine learning studio is right now available here, correct? So this is done. So right now we need a data set to proceed with. So data set comes in various sources and various forms, but rather we'll go on with a simple example as of now. So I'm going to use an Azure open data set, so where you can simply get started with, but rather you can create your own data set from here. You can upload it from your local file, or you can pull out from a data store or from web files. So if you have a data set as a URL, you can just fetch it from here. And I have already go and create from open datasets. I have selected diabetes dataset. So I'll explain what the dataset has. So it's like we have around 10 features of to decide whether what is the level of diabetes that a person has in that. So that's the whole dataset is about. So I've already created my dataset here, so which was created yesterday. So everything is pretty new. Don't worry. So this data set is created by me, and you can also view that, and you can explore how it is right now. So it takes a couple of seconds to load on. So we have around ID, age, and so on so features, and Y is the level of diabetes that a person has. So this is our data set we have right now, and this is what we are going to use in our machine learning. So once data set is ready, go and create a compute. So whatever you are going to execute today is like we need something to run machine learning code or whatsoever. So you have to create a compute. So while creating compute, just go ahead, go with the defaults, or if we need a higher specification VM, you can go for it. And once that is done, you can log into your Jupyter notebook of that particular VM, the compute resource we have created. So that's where this has popped here right now. So this is our script file. So keys is where I have stored my essentials and relevant stuff to access my workspace. So you can create, I will let you know where you can find those necessary keys. So now that we have created our data set, and we have created our compute resource, and we have launched a notebook. So we are all done. So now that our code is like launched a notebook instance, now we are good to go with the coding part. So first thing is workspace. A workspace is nothing but what we have seen so far. So workspace is where we all manage our all resources in machine learning. So when it comes to Azure, we can create one by programmatically, but rather I have already created an UI, so I'm going to access it right now. So you need four things to actually fetch your workspace. So which is like the subscription ID. Subscription ID refers to the subscription of your Azure account. And second thing is resource group. So when you actually create a machine learning resource, you'll be actually mentioning something called resource group. And what is the workspace name and what's the workspace region. So once that is done, you have to run this code and your workspace will be fetched. So you can fetch your workspace using these four parameters, and or else you can always create your workspace using this one. And secondly, compute. So I have shown you how to create a compute in virtually, I mean in your UI in your machine learning studio. And this is how you can also create it programmatically. So I'm going to create a cluster called CPU cluster, which has, I can show you. So this is where I'm going to execute or do whatsoever stuff I'm going to do right now. So I have created and I've already run my cluster. So it's already created here. The reason why I have already executed and kept this notebook ready is that it takes a couple of minutes or seconds for each time when I execute something. But rather the output is always available, so you can just go around how it works here. And third one is experiment. So as I said, like an experiment in machine learning, Azure machine learning is like you can do it's a named process of doing multiple stuff in something like that. So let's take a simple example. So if you are a scientist or doing some sort of research work, everything comes to a part where you experiment with things. So you have to name your experiment and you have to log what all the stuff you do within a particular experiment, right? So this will actually create have a particular you can create an experiment, and every time you run something within your experiment, that will actually count as a run within a particular experiment. So this is called a run context. So every time you run something in a particular experiment, that's called the run context, and you can log several values which is associated within a run. So this is I'm going to name my experiment as my experiment, and this is the workspace. So since we have created a workspace and we have fetched it here, so that's WS. So I'm going to create a workspace, and the name of the workspace is my experiment. And run actually will help you to start logging things which is actually going inside. So it's like from here to here, whatever you write something within the code will be logged and using several ways. So you can use .run.log to log several values, and this is where your insights and your logs data comes into place. So you can write all your machine learning code, and when I execute this one, I will show you like this is already run. So if I'm again executing the same thing here, so it's like showing me like uh, it's currently getting executed. So let's wait. Okay, so it has executed. So it showed me hello world. So I will show you what really happens in the dashboard. So when you go to experiment, so this is called my experiment. So the recent one was submitted at 5:18 p.m., which is correct. So which is like this is a run. So whenever you submit within a particular experiment, this will be counted as a run. You can store the metrics, you can store the tags, you can add description to the particular workspace so that you can know what really you have done in each run of an experiment there.
Vivek, can you just increase the font size of the browser? Like
Yeah,
it's
okay, great. Is it visible right now?
yeah, much better.
Okay, great. So what I was about showing here is that we have an experiment, and each experiment has multiple runs and run IDs associated with that. So every time I run something within an experiment, it is counted there. And I can log and add tags to it and add metrics to the particular run and description to it, so that you can keep log of whatever you have done in so far in a particular experiment here. So now comes the data. So since we have already created a data set in using UI, you can also create it programmatically always. So let's see what we have here. So we have data store. So data store is nothing but a collection of data sets. And what are the data sets we have right now? So we have it's executing because it's querying the data store and retrieving the names of the data sets we have. So it might take a couple of seconds to execute. So this is called the data set. So when we go and check here, we already have the data set here, so which is diabetes data set, which is the name which I had given to it. It is taking a couple of seconds, so let it run, so it's not an issue. So this is the data set what we have, and I have just printed it out. Or if you really want to upload your own data set, and you can do it with this code. So I have rather than missing that out, I have used that code, and you can just uncomment it and run. So imagine you have a data set in the as diabetes CSV in your data folder. You can just upload it using this one, and you can register the dataset as what you have registered here as diabetes dataset using this code. That's it. So when we actually run the datasets, we have a diabetes dataset, which is what we have created, and version 1. So when you actually manipulate or do something to your particular dataset and you re-upload it again, which means like the version will get changed according to that, and it will be turned by the name here. So every time you use diabetes dataset, it will actually have a version. The version will be automatically managed by the Azure itself. And now it's like we have all the necessary stuff for us to train to create the resources and so on. So we are now done with the necessary stuff. Now it's us to train the model and see how it goes. So I have created a sample folder for all the necessary files to keep there. So you can also create a simple folder in your Jupyter notebook or your VM which I've spun. So, and I'm going to create a ML script. So ML script actually has these values. So this is nothing but your actual machine learning code which comes into play. So I'm going to pass two parameters here, so which is like where the input data is and what is the value of alpha in the model I'm going to use. The model I'm going to use is rich, so it has alpha as one of the hyperparameters. So this training script actually takes alpha as an input, and it replaces there and runs according to that. So now we get the context of the experiment, and we have the data set ready, and I'm going to load the data set. And as usual, like when it comes to machine learning, you have to split it into test data and train data, and I'm doing that here, and logging the data in that particular run of that experiment as alpha value, and this is the alpha which is used in that particular run. And I'm fitting the model and so on. And when we actually do the prediction, I'm going to log the data value of the root mean squared error. So this will actually help us to understand in each run of different alpha values what was the value of the RMSE, so that I can pick out the best model out of all the same. So instead of throwing away the model right away, I'm storing that the models in is called model alpha with the what alpha value I'm using there dot pickle. So I'm using a pickle file here, and I'm storing that in a file. So what really happens here is that you're not going to execute this training script in your local compute or in the Jupyter notebook. Rather, you'll be creating an environment and a compute resource where you'll be executing this training script in an actual compute power where you'll be actually dealing with. So the compute might be according to your machine learning capabilities or how much you compute required to do the same stuff. So that's where you'll be actually doing it. And yep. So before we actually know, since you're going to use other compute power and compute instance, it's nothing but a VM with no installation or nothing done. So it's like a Docker image, and you have to install the necessary to create an environment there. So these are the necessary stuff which is required us to create to run these particular stuff. So do all the pip necessary and install the necessary environment files here, and then go on with creating the environment. So I'm going to create an environment from the Conda specification. So which means you can either create it using pip requirements if you have a pip file, or what type of pip version you have to use, or you can just use a Conda library, Conda specification to install your particular packages of your Python libraries. So environment.yml file is a file which I've written, so which is already here. So it is here, and I'm going to install all the necessary in that particular image, and that will be called as experiment env. So this will be used in while I'm going to train my model. So it's similar as of you creating a virtual environment in your local system, but rather, since you are dealing with the cloud, you have to create a virtual environment in a virtual machine. So that's how it really goes here. And I'm going to fetch the data set here, and I'm going to create 10 different models of different alpha values and see which alpha value gave me the best result out of all. So each alpha value corresponds to a particular run in an experiment, and this is how you are going to run a machine learning model. So script run config is a class which is used to run a machine learning model. So I am using diabetes training.py. So diabetes training.py is the one which you have written here. So as the training script, what you're going to take. And second one is the arguments. So we need two arguments here, which is the input data and alpha value. So if I'm going to run it loop, and I'm going to pass alpha value one by one, and I'm going to create a run there. And where this script should be executed, I'm going to execute in CPU cluster. So CPU cluster was a compute resource which we had created here. So as if you remember, so which has a standard D2 V2 as our VM size, and the minimum number of nodes which was 0 and maximum is 4. Okay, so let's go back. So now that is done, I'm going to specify the environment here. So the environment which I have created from the YML file. So this will configure like, okay, the experiment folder, you have to pick up the diabetes dot underscore training dot py. You have to pass these arguments. You have to execute this particular script in this particular compute cluster, which has this environment as the stuff. So this is how it goes. So once you create a script config, you have to submit the experiment run. So I'm going to turn this experiment as MLCD Stein database diabetes. So if you go to experiments, I have two different ones. This is the sample one which I have executed my hello ML world. So this is where you are going to execute different runs of your machine learning model there. So there was a particular error, but I didn't mind it. So it's like it's going to run 10 times. So each time is configured as a run, and you can see the logs of the particular run here and everything. So imagine like actually I have stopped it before completing 10 times. So I have actually run it only for 4 values. So it's like 0 0.1, 2, 3, and 4. So we'll be actually dealing with only 4 models here, and let's see how it goes there. So now that when you actually execute this one, you will be actually receiving this one, and what was the alpha value and what was the RMSE. So these were the things which were logged in the particular run. So if you go to the run and pick out this one, it shows that the alpha value is 0.5 and the RMSE value associated with it was 56.628. So this was the tags which I've given here, and this is the value. So based on these metrics, I'm going to pick out the best run, that is which has the best model with it. So how to actually fetch out the best run of the models? So when I'm actually printing out all the models on all the metrics, I'll be able to see here. So how it goes and everything. So this is where a models class comes into picture. So when it comes to models, you can create as many models as you want, and each time you create a model, it has its own version number which is associated with that. So I'm going to pick out the best diabetes model, and based on how I'm going to pick it out. So I'm going to pick it out based on what was the alpha value and what was the RMSE value. So based on the RMSE value, I'm going to decide that's the best model for me. So I'm going to list down to see which are the models which I have in my particular data. So it's like I have these diabetes model. This is just ignore the last one. So diabetes model of version 7, 6, 5, 4, and I have deleted 2 and 3, so it's not there right now. So I'm going to pick out the best model by comparing the RMSE values with this one. So I'm going to keep a threshold as 100, whatever, like the lowest RMSE value will be the best model we are going to secure here. So the best model version, I'm going to get it, and what will be the best model from that. So I'm going to iterate to these diabetes model, and based on the RMSE value, I'm going to see which is the best one. So I'm been printing the best version. So the best version happens to be diabetes model version 4. So let's go and see what was the diabetes model version 4. So this is the best model we have got so far. So of alpha value 0.1, so which is great. And now that we have actually done in we have created the directories, and we have creating your ML script, we have created an environment, we have trained the models, and we have retrieved metrics and models. So this is what we have done so far. So uh, since we have different models associated with that, and we have decided which model should we have it in our cloud, and which model we should prepare for our deployment. So we have actually done the second one, second section as well. So model management. So we maintain different versions, done. We have registered the model with Azure ML, which is also done, and loading the preparing for your deployments. We have picked out the best. Sorry. So since we have also fixed that the best model was the version 4 model of diabetes model, so I'm going to see how to deploy it. So next, let's consider on the deployment part. So this is where our main focus also comes into picture. So I haven't much discussed on this particular topic in elsewhere. So this is the first time I'm doing this, and there is a lot of few things which I also like to say as part of my doing this particular deployment stuff. So I can give you a couple of tips and tricks where you can do some real good values, and where to use when and everything. So when it comes to deploying a model, as usual, you have to create a scoring script. There is a particular format of scoring script, which is like how to load your model and how to do the prediction, and what will be the inference and deployment configuration. So inference is where you are going to make a prediction from that particular model, and deployment is where, like, where and what is the VM I should use, and what should be the configuration of the VM and everything, and how can we actually deploy in a model. So there are three ways to do it. So if you don't want to actually leverage the cloud, but you want to just test it out in a local system, you can deploy a local web service and see how it works here. So that's a local compute. And second one is using AML compute, which is uses Azure container services. So with these, you'll be actually be able to deploy a model in container services. And third one is Kubernetes services. So when it comes to the difference between the three is like we will discuss as we go by. So let's jump back to the code. So I'm going to, as we said before, I'm going to create a scoring script. So I have named it as a score diabetes, so which has two methods. So all scoring scripts should have two methods, which is called init and run. So this is a thing which is recommended by Azure ML. So you have to follow this one. So ignore the stuff which was actually I was doing to experiment. So this works. First, we need to fetch the model. So we know that diabetes model of version 4 gave us the best model. So I'm going to fetch it. So diabetes model 4, and I'm going to load that model using joblib. And this will be executed only once when you actually deploy your cluster, and run will be executed every time you make an inference call to it. So we have to first load the model and keep it ready, so that whenever you send a raw data to that particular machine learning model, you have to respond as quickly as possible. So run method actually takes the input, and it does the prediction, and it returns your prediction values. So that's the scoring script we were talking about. And now we are going to use a local service compute. So every deployment has two things, which is inference configuration and deployment configuration. So inference configuration is handled by inference config method, I mean the class. So you have to pass an environment where the scoring script will be executed, and what is the file you have to execute there. So as we know, like, we already have the environment created, which is like the env, which has all the dependencies which we required to use. So I'm going to pass this env as the environment. And when it comes to deployment configuration, you have to mention which port you have in the local host you have to run this web service. So I'm going to run that in 6789 web port. What's the name of the model, and so on. So So when you actually click deploy, you can specify like this is the name of the deployment, which is a local service model, and what model I'm going to deploy here. So as you know, the model which I'm actually got here is fetched here is the best model. So I'm going to pass it the best model here, and third one the inference configuration, deployment configuration, and so on. So when you actually run this one, you'll be actually able to get a URL where you can actually do a post request and get your responses. So let's see how this works. So I have actually, it will take a lot of time for us to deploy because it will create a Docker image, install the necessary environment files there, and then keep your model ready for scoring script. But rather, since I've already executed and kept it ready, your scoring URL is already ready here. So you'll get a response as a scoring URI. So from the service. So from the service, I'm going to send this particular data values and see how it goes. So let's check it again. Let me take this stuff alone and see how it works. So as you can see, my local web service is running at localhost 6789. So if you actually print that here and see what we get, so let's see how it goes. So take out the indentation necessary. Oh, I'm sorry. So got okay. So I'm sorry. So local service is the name of the service we have here. So let me replace it. So print scoring URI. So this is where you have to send your predictions as your data body, and you'll be actually getting a response from it. So it's nothing but I'm sending out 10 features, and I'm going to get a response value from that. So these are the prediction values for this first data and for the second data. You can send as many data as you want. So what really happens in the background is what you're going to discuss right now. So when you actually deploy this model, what happens is that there'll be a Docker image which will be pulled out, and those environment file, YML file, what you have mentioned, those necessary dependencies will be installed there. So once that is installed, your script file will start executing. So the init method of your script file will get executed. It's not your actual init double underscore init double underscore what you use in your as your constructor in your Python classes. It's not that. I'm sorry. So it's just an init method. So with nothing else. So this is where you'll actually load your model and keep it ready. So this will be done only one time when you actually deploy your cluster, and the second time whenever you actually call for your prediction, this method will be called, and the raw data what you pass as your from your body, so that will be taken, and that will be used as your particular here. So once a model is predicted, that will be given out, and that's you'll be returning as JSON dumps, and that will be the response of your actual the prediction what you made. So we have actually done a local service, and we have actually seen how to do a request model to see how it responded perfectly. So this is what is the actual use of using a local computers to see is the deployment and the model is working fine or not. Before I actually pull out a compute instance and deploy in your cloud, it's rather best to test it out in your local and see how it works. So this is where actually you have to do stuff. And second comes Azure container instances, and third will be actually discussing on AKS. So what is the difference between actual computer Azure computer container instances and Azure Kubernetes services where you have to deploy your model is at? ACI is actually quite managed by Azure, but rather when it comes to Kubernetes, you have to manage few things on your own. So which means like you have to in a container instances, you have to just mention that I need one CPU core of this much memory, and Azure will take care of your compute and everything. It will create for you and it will keep it ready. Hold on a second. So before we continue, let me see if you have any questions here so far. So if you have any question, You can drop it in your particular stuff. So uh, before, I will just take a couple of few seconds to drink water and so on. So meanwhile, you can drop your questions right now, and I will get back to you. Right.
Yes, yes. Please drop your questions, and we'll be answering those questions.
Great. So if we don't have any questions, we will carry on with our presentation right now, and we will take the question at the end as well. I'm sorry, where did I keep my? Okay, it's in Safari browser. Fine. So as we were talking about, we have two different ways of deploying a model. Like we discussed on local, and when it comes to cloud related aspects, we have two different options. So which is what container instances, and second thing is Kubernetes services. So these are the ones which we actually use it for real time predictions and in production level as well. So you have to concentrate on how much cores do you really need, and what will be your traffic intensity of your machine learning model. So if you're actually going to use it for so many calls, you have to deploy a very rather good compute instance. If not, like if it's rarely going to be used, you can use a minimal, so that you can reduce the cost associated with that. And it is pretty much everything is pretty much the same. You have to use a deployment configuration for as compared to ACI web service. Rather, we used local web servers in our earlier approach. And once that is done, you have to just wait for the deployment, and your deployment will be done. You can get the configuration, and you can do the same. So here you'll be actually able to see the endpoints which are created so far. So diabetes model 4 was the best model, so I have created a couple of endpoints for that. So as you can see, ACI service model is the one which you have created. So what was the REST endpoint you can use to call that method and everything? Is it a key-based authentication? So if you want to really secure your connection, you can use this one as well. And what was this GPU and the memory which was allocated with that? And this is the actual compute. And to test it out, you even use it as in your UI. Rather, I would like to go and see in the code environment as well. So we have the necessary code which is given by the Azure itself. Let's copy paste and see if that works. So let me go back to my code. So it is as same as what we have created. This is the URL which we are going to use to do the this one. So let me run. There's some error. So it's not an issue. Like rather, I will go on with my approach of code. Uh, so as what you have created here, let me again get the scoring script and see how it goes here. So what the scoring service we have used? We have used ACI service. Let's guess scoring URI for that. So let's print the scoring URI, and let's send the same data and see how it works. So this should actually work. Yep, it pretty well works. So this is a actual REST API which where the model is deployed, and this is the prediction which I have got. So since this notebook is actually hosted in cloud and is actually interacting with another cloud resource, which is the container instances which is deployed in Azure. Which this will actually show you like how easy and how much latency it takes along with the prediction. So we will actually discuss. I want to give a little bit a mention on the latency part a little bit later, and how you can actually reduce the latency when it comes to real-time environment. So this is one approach, and when it comes to AKS, so Kubernetes services, there is a one difference between the two things. So where, as I said, mentioned before, this is actually managed by your Azure ML itself, which means you don't have to spin your own VM. Rather, it will deploy its own VM. You have to just mention the configuration you require. But rather, when it comes to Kubernetes services, you take care of the in charge. Like you will decide like what type of Kubernetes cluster do I need to spin up, and what will be the configuration of that particular compute, and so on. So here I'm going to spin up a cluster called AKS cluster 1. So this is where the Kubernetes cluster, and I'm going to provision a standard D2V2 compute, and that's where your above which your Kubernetes cluster will run. And Once that is done, it's pretty much the same. And what should be the configuration for this deployment? I just need one CPU core and one memory GPU. That's it I require for my particular prediction. The reason is that since you have actually provisioned this VM, it's not necessary that you have to use the entire compute resource for your one particular web service. Rather, you can allocate the same compute instance for different web services, and that's how you will actually minimize your cost, and you'll also increase your productivity as well. Productivity in the sense like with low efforts, you'll be actually able to get good results, and it's very good for your company as well. And pretty much the same, you have to mention that the deployment target is the AKS target, so which is the cluster which I have created. And once that is done, this is where you can see the models, and let me show you the endpoints. So this is same as what we have. So AKS service model is actually using a Kubernetes compute type, and it's healthy. And how we can test it, we can just test it by sending here, and this is the URL which is required for that. So this always, your Kubernetes services by default will use key as an authentication. You can enable it in your container instances, and by default is enabled in Kubernetes services. And for that, you have to require to fetch the keys to run the particular instance. So I'm going to deploy it. I'm going to get the scoring URI. I'm going to get the key for the authentication. So for getting the key, you can just need to get the service.get keys, and with that you'll get two different keys. One is primary and secondary. You can use either of those, and you can use that as an authorization bearer and send the request as possible. Same. So let's again try it out right now and see how the prediction comes. So here we go. So it's AKS service. And one more thing, we do require a key. So let's get the key as well. So this is a header I need to replace with my actual header. So one more thing, since this is AKS service, let me get that and replace it here. Yep. So this is the Kubernetes clusters, this one, and this is the prediction which we have got. So now that is done, we are actually able to get the prediction as quick as possible. So since before we move on to the next aspect of how to monitor your deployments or model, I would like to mention a simple stuff. So the latency. This is what I actually personally faced, and I was able to recover from the latencies issues which I was facing. The main reason for this comes in two places. So one is the compute resource, what you're actually deploying, and second thing is where you're actually deploying a compute resource. When you actually see the deployment perspective, I have created this notebook in Central India as my region. So, and you can also notice in one other place that this container is also present in Central India, which means you have to select the closest zone where you're going to host your particular VM, so that the latency which is involved in calling the predictions will be drastically low. To show how the latencies and region latency which is involved in that, just go and see Azure region latency, and that will show you like what was the round trip latency figures for each stuff. So from your current region, you can compare how is your latency speed going on. So this is called Azure speed. Let me increase the size. Okay, so it's going out from somewhere else. So we are from India. So let's create, where's India? So there are multiple India. So let's see like what was the difference in different Indian regions as well. So did I miss anything? Geo India, so Geo West, and South. We don't have South America, US, Europe. Yep, that's done. We select Central India. Here it is. East Asia. Let's see. So this is the difference of the latency which we get. See, when it comes to latency, we have average of this, what it goes. So central India is quite near to me, so that's where I have the less latency. To see how it works for you, you can select what is your closest data center and how it works for you as well. So this is what I actually used, and by provisioning a better compute, I was able to also do the predictions in a faster time. And since the model which we are using currently is very less and very lightweight model, it does not matter. But when it comes to a full-fledged machine learning model, you have to also consider the part of where how much memory do you really require to do the same and everything. So that's the thing. So now that we know that the service has been actually done, and let's see like what are the logs we get. So logs will actually help you to see is there any errors in your deployments, or the deployment fails at any particular point of time and so on. So in get to the service by, you can just get the service and print the logs. So as you can see, these are the times I have actually done the predictions. So the recent one which I had done was around 12, 17, 15, which is around UTC, which means like very close to us. So let's see, I'm again doing it, and we can also notice the difference in the logs what we get here. So so it was 1217 was the recent one which earlier showed, and now it showed 1221. So which is the reason. So and also all the errors and everything will show you here, so that you can monitor your logs. So to monitor your models, there are two ways. One is the log files, and second thing is application insights. You can go here, and when you actually create an endpoint or do something, so you can mention what is a create endpoint and so on. So I will show you how to enable the compute here. So it's like test. You can go for either managed or Kubernetes. So there's already a cluster which is available. You need a token or key, and what model you are willing to deploy, you can deploy it right away. And if you actually want to enable the application insights, you'll be able to see the logs in much more detailed way. And when you actually log few values in the log files, you'll be actually able to get those values in the insights as well. So I'm not going to do it right now, but you can surely check it out. So none of my endpoints does not have any insights so far, so I haven't done that. So when you actually see my web services does not have any deployment stuff. So these were the logs which I are able to get from that particular thing. So that's it. So the application insights is enabled. It's actually false. I haven't done that. So if you actually allocate as yes, you'll be actually able to do that. And how to enable your application insights, you can do it in two ways. So it's like I'm going to just create another scoring script, and I'm going to just print the values in that particular in the scoring script itself, so that these values I can get it from the application insights. So you have to just do the necessary same steps, but only one thing in the deployment configuration, just mention that you are using uh, enable app insights equals to, that's it. By default it's false. If you enable that, you will be actually able to get through the same. So that's the what we have discussed so far. Let's go back, jump back, and see what we have done. So we have created a scoring script, and we have created an inference and deployment, and we have done tried and deployed things in three ways. One more important thing, let me go back to my presentation. Sorry, to my this one. As I was actually insisting on uh, deleting or managing resources. So all the web servers are active right now. So if you would just want to delete it, so it's like ACI servers dot delete. This should delete my service. Hope so. This is the correct syntax. So by this way, you will be actually able to manage and delete the resources whenever not necessary. So it's like I have deleted a computer container instance service. So let me go back and check if that really happened or not. So where should I go? And endpoints and ACI service endpoint, which is here. Yep, it got deleted. If you actually noticed a bit, it disappeared from here. So you won't be actually able to call ACI service as you have deleted it. So let me again go and see if I able to run that value. So this is No, it cannot, because your service has been deleted. That's the main reason. So this is how you have to manage, and if you can delete your models which are not usable or anything else, and you can do it in UI as well as you can do it in this as well. So for other aspects of the ML ops, which is like creating pipelines and so on, so we'll be actually discussing in future sessions. So I'll be actually talking a lot on how to use pipelines. But if you're really curious, I will recommend a blog where I have implemented one of the pipelines, which is actually good for you to reuse the pipelines and different stuff. And performing hyperparameter, which is what we have done so far, and track and monitor models using insights and logs, we have done that. And what is a model explainability and fairness? So to explain which model actually done better and why it has done better, we have an service which is available in Azure. So they will help you to determine how well it was able to predict the values. So we'll talk on those post prediction deployment aspects a little bit later. And AutoML, imagine you have to do all these stuff without single line of code. You can do it like and it takes care of all the necessary compute, and also your data pre-processing, your models, training on different hyperparameters, and it will give you the fetch you the best model out of a huge corpus of models as Azure has. And also it will give you the deployment as easy as possible. So we have automated ML. So to know more about automated ML, I've done a previous session. You can check it in your in our YouTube channel, Azure Developer Community, where you'll be able to find my session on AutoML. So I think that's it as of now, and I'll take questions if there are any right now. Great,
Yeah, sure,
awesome,
Vivek. This was a great session. We do have some questions, so I'm
sure.
just sharing on the screen if you can see.
Yeah, like Kubernetes is just like Docker. It's like you have to use a Docker image in your Kubernetes, right? So it's like when you actually notice the logs, let me show the logs as well. So when it comes to deployment aspects, so it will actually create a Docker image. It will install all the necessary files, and it will deploy the Docker image in your compute instance. A compute instance may be your local or your container instances or your Kubernetes. So everything has a Docker image as its base. So here also, if you see, like there is a Docker image which is pulled and done here. And when it comes to ACA also, it has a container registry which has an image, and this image will be actually used while you do a stuff. So, and also when it comes to Kubernetes also, it does the same. It has a container registry which has a Docker image, and that Docker image is used to deploy this AK service. I guess that has answered your question. So
Great. The next question is, I have shown it on the screen.
okay, thanks for a great session. Okay, welcome for that. So how can we take care of data versioning? Okay, that's a good question. So I haven't explained much on this session, but I will also take a minute to do that. So when it comes to data versioning, let me go back to my stuff. So we have different data sets. So right, so we can create as many data sources and data sets as you want. And when it comes to versioning of that, let me show a simple example. So we have a data set here, and here we have we have only one data set right now, diabetes data set. So rather, now imagine I'm going to create a subset from this particular big data set. So let me use this one and see how it goes. I guess this should work. I haven't executed it before, so but it should work. So it's going to take a subset of it, and going to convert that as a data frame, and I'm going to register on this as another version of the same data set. So what will happen in that scenario is that, so when you actually execute this one, so when you list the data sets, you'll be actually getting diabetes dataset version 1, which will have the full data set, and there'll be another name on the same name because we have used the same here. So which will have the version 2, which is a subset of the version 1. So that's how you can use the name as your version, and you can keep do different versions of a particular data set. So it's like when you do some pre-processing and you want to maintain as a version of raw data, second version as a pre-processed data, and third version as a dimensionality reduction. So when you're done, you can maintain different third version and different versions of the same data set in this manner. So all you have to do is use the same name, and your Azure will take care of your versioning part. So
Great.
can you redeploy models as AKA services using blue-green or canary strategies? I'm not sure about the process, but I can refer and get back to you on this particular concept. So as what we have seen so far is like we have used a Docker image and we have deployed your AKS cluster. And when you do that, you'll be actually redeploying that on the same aspects. But I can surely check this on your question and get back to you, since I'm not very much clear on the answer. So thanks for the question as well. So can you share the data set? Yep. Before we conclude, I will let you know where you can find the GitHub profile and my notebook. The entire
Great.
process we covered today. Did that cover CI/CD pipeline? No, we didn't actually include a CI/CD pipeline, but I will be happy to show you that one. So when it comes to pipelines, you can create train pipelines, deployment pipelines, you can reuse the pipelines from whatsoever one. But since I don't really have the code right now for it, but I can show an instance example for that in my previous one of my blogs. So my blog was on how to deploy an end-to-end COVID-19 forecast model using Azure ML. It was done last year. So in that, I've actually used pipelines, and I've scheduled the pipelines to be executed every single day. So that's how I done. So pipelines will be actually able to, you have to just create a pipeline, and that pipeline will take care of the rest of the stuff. So creating a pipeline script file. So this is a script file, need to have it there, and I can use that as this one. So this is my pipeline script. So it is broken down into a couple of files. So this entirely consists of my pipeline. I want this pipeline to be executed every single day, as I need to predict it on a daily basis. So I created this pipeline using pipeline step, and I scheduled this pipeline to be executed every single day. So that's how I have done. So you can take a look at the pipelines and where you can actually do the necessary pipeline stuff in Azure ML. And coming back to this your question, so everything is real time right now, and when you actually redeploy or do something, Azure will take care of make sure that this your real time deployment does not go offline when you do sort of stuff. So where to
Vivek, can you
find?
just share the link here in the comment section? Can you just
Yeah,
tell?
1 second. I have got it. So I have actually taken all those. I have a specific repo for all maintaining my Azure related machine learning stuff. So even you can find the code here. So actually, this is a last month code. I will update the same because I've done a little bit rework on my code as well. So here you can actually find the necessary uh, code.
Great.
I guess now it's on the screen. So this is where
Yes,
you can
yes, yes.
uh, find your actual code. This is like GitHub Vivek0712. That's my profile, and you can actually take a look at my profile. So there actually I will done all the code works, and this is there. Notebooks also will be available. I will update this with my current notebook. So one more thing, and if you are actually starting out with new aspects of machine learning, I have just started a block series in dev.to, which will actually cover all those topics which I've discussed today, but in a very elaborate manner. So you can check out my dev.to profile as well. So my dev.to profile just started with machine learning, so it has basics of machine learning and getting started. I'm right now writing my third blog, which is on how to train and deploy. So you can stay tuned to get updated on all the machine learning stuff which we have discussed so far. So you can also take a look at that whenever free. So next question. So one more question. Okay. How could we monitor our hyperparameters? Suppose with different data, we get different hyperparams. How to take care of that? So the reason for that is like for each model has different hyperparameters, and you can use different data sets for different value as well. So I can simply explain you in this way. So you can monitor by just logging the data in your run experiments. So you can use different data sets in different runs. It's not necessarily that you have to use only single data set in a single run. So you can actually maintain the data sets versioning, and you can mention the version of the data sets by passing as here. So since I have only used one data set, I'm just using it here. But here you can just pass on your different data sets and see how it makes a difference between different versions of dataset and so on. So, and you can just log the data using run.log. And when it comes to run.log, you'll be actually able to, I'm sorry, one second, home. So, it will show you a graphical approach of what all happened, how many has completed so far, and what was the value which I logged in each run, and so on. So with that, you'll be also graphically able to figure out the differences, as well as the values which you need to know from each run of your experiment. So this will be helpful for you to maintain the different versions, use different versions of data in different runs, and also you can play with the hyperparameter of a single model or a different models in different runs of the parameter. So you can schedule your experiments and your run based on that. So I guess that answered your question. So, what's the difference between AI platform and Google AI platform? It's like those are two different cloud providers. So each has its own features and own way of implementing stuff. So it's not necessarily I can pull out a pros and cons. It has its own pros and cons. It's like it depends on the business requirement and what you really want to implement and so on. So I guess you can explore both, but it depends on which one suits for your particular business and personal requirements. I can't deep dive into that right now, but sure, that was a good question. I usually get a question when we have to compare different cloud providers. So since we are from Microsoft, I would vouch for that.
Yeah,
So,
exactly. Correct.
so
Yeah.
the reason is that I can pull out a simple example. So we have seen from end to end. So whatever we have done so far, we were able to do that in 1 hour of simple expertise and machine learning. So if you're really a beginner or a professional, you can use the leverage all the features in Azure ML, which will actually make your lives pretty much easier. With cost on the other side, but on the features, it has a very good impact. So as I usually use Azure ML for my work on daily basis, it's wonderful and it helps me to streamline my processes and maintain everything as of now. So, yep, I would personally recommend Azure ML as well. So we have one more question. Thank you for your wonderful comment. Don't worry if you have a limited knowledge or stuff. You can still follow the video blogs which were uploaded earlier, or you can follow my particular blog series so that you can catch up from the scratch as well. But thanks for attending the session. I hope it was helpful for you as well. Great, thanks. And how do we get okay since you're from Azure ML for learning or practice, so a very good question. So since we were really dealing with the professional aspects, so let me dive into the students point of view. You can actually use Azure ML for free if you use an Azure free account, and secondly, without even using an Azure account, you'll be able to practice this for free. Let me show you how. What you have to do is go to Microsoft learn. So this is where all the documentations for everything is available here. It's like you have to just search for the necessary stuff, and you'll be able to get through it. So this is where I got this one, and you can learn step-by-step approaches of how to do and what to do and everything, and you can do everything from here. So as you can see, if you want to really practice this one, there is something called exercise. You won't actually find it in all the learning docs, but you'll be actually able to find in few of the stuff. So there will be actually spinning up a sandbox account, and from the sandbox account, you'll be actually able to run this experiment on this particular thing. So do check out your uh, do check out the Microsoft Learn documentations, and you'll be actually able to do the necessary there. And also, you can also try applying for Microsoft Student Partner. You'll be getting credits to work on Azure as well.
Yes,
So
great. Yeah, Microsoft Student Partner is a great platform. Yeah, we should apply for. I mean, every student should. So I think there are no more questions, Vivek, and this was really amazing
great.
sessions. So thanks again, thanks so much, and thanks the audience. If you have any further questions, you can always reach out to us via the any like GitHub or the YouTube or any like. So we will be happy to answer those questions.
Great, awesome. So let me share my profiles and social media so that you can also get to reach out for me. So do sign up for Azure Developer Communities. If you are interested to organize, you're free to do so. And we are running in more than 8,000 plus. So we have always get mentioned in Microsoft newsletter for our different session, code blocks and everything. You can find us in Meetup, Twitter, and LinkedIn. And these are my blogs where you can find in dev.to and as well as in Medium. So if you want to connect with me to discuss more on machine learning, so you can ping me in either in LinkedIn and Twitter. So Vivek Raja PS and Vivek Raja 007 is my Twitter handle. You can ping on the questions and we can connect offline after the session to discuss more on that. And I guess that will do for the next.
Thank you. Yeah. Thanks again. Thank you so much, guys. Have a
Thanks for
good day.
sharing. Yeah, thanks
Yeah.
for hosting me, Deepak. It's so great
Yeah.
here.
It was great. My pleasure. Yeah, thank you. Have a good day.
Thank you.
Bye.
Bye.